Hello viewers, today we will try to understand how a turbocharger of an IC engine works. Let us start. Turbocharger, which is used in case of IC engines, it may be a spark ignition engine or CI engine, compression ignition engine. I have drawn already a single line diagram in order to understand how it works. Today we will see how it works. What is in a turbocharger? In turbocharger there is nothing. There are two impellers coupled to each other on the same shaft. One impeller is known as turbine. This is turbine. Small turbine, it's a very small turbine. Okay, and the other impeller which I have made here is known as compressor. Okay, this is engine. This is an IC engine. In this engine we have, as you know, there is a cylinder, there is a piston, connecting rod, crank and crankshaft. It rotates like this. It has two manifolds. This is inlet manifold. Inlet manifold, and it has its inlet valve. Okay, it has an spark plug, SP denotes for spark, or it may be an injector. In case of SI engine it is a spark plug, and in case of CI engine it is an fuel injector. Okay, another passage here is, it is known as exhaust manifold. Okay, and then this exhaust manifold we have exhaust valve as well. Okay, this is it. Now let's understand how this turbocharger works in an IC engine. The outlet passage, which is also known as exhaust manifold, the direction. Okay, this is the combustion chamber. Okay, what happens when as you know, in IC engine there are 4 strokes. One is known as suction, second is compression, third one is power or combustion stroke, and fourth one is exhaust stroke. Okay, there are 4 strokes. What happens when piston goes from this TDC to BDC? It goes from here to here, from TDC to BDC. Suction takes place, air gets sucked into this combustion chamber. Okay, then compression takes place. Piston first of all comes down, this is suction, it goes up back from PDC to TDC. This is compression stroke. Then it expands by the combustion of gases. This is power stroke. Okay, then fourth stroke is when it comes back from BDC to TDC. This is known as exhaust stroke. Exhaust, as the name indicates, it has to exhaust the gases which are burnt gases here remained in this combustion chamber. These gases are to be expelled out from this combustion chamber. This inlet exhaust valve opens at the proper timing and these gases come out, as you can see from these arrows here and this line goes like this, and from here what happens, before directly going out through the silencer, these exhaust gases are supplied or passed through a turbine, okay, small turbine T, where these gases expand and rotate the turbine. These gases having the high enthalpy rotate the turbine, okay, and then are expelled. Then these exhaust gases are expelled through the silencer when they come out from this turbine. As I already told you that this turbine is coupled or is on the same shaft of the compressor, which is also an impeller coupled with this compressor. As this rotates by the expansion of these gases which flow or pass through this turbine, rotate the compressor as well. As you know, the function of the compressor is to increase the pressure of the inlet air. This is atmospheric air. When this atmospheric air is sucked through the intake system of the engine, it gets first of all compressed in this compressor. It sucks air from here and it gets compressed by the action of this rotating impeller of this compressor. These compressed gases, these compressed air is then supplied, you can see by these arrows, is supplied to the engine. Here when the inlet valve opens during the suction stroke, these gases are supplied which are highly compressed, okay, and supplied to this combustion chamber. And what happens by this, the pressure, the density the density of the air gets increased. Means in case of a turbocharged engine, we have higher amount of O2 in it, because as the density of the air increases, obviously the oxygen content in the air also gets increased. So we get higher oxygen in the combustion chamber, which is required for the combustion function. This is the function of the compressor. What is that? I will repeat. The compressor simply takes air from the atmosphere, it compresses it to the high pressure, okay. The main aim of the compressor of this turbocharger is to increase its density in order to increase the O2 in the atmospheric air, so that the complete combustion, the term is the complete combustion of the air fuel mixture will take place in this combustion chamber and we will get the maximum power. And hence this turbocharger actually increases the volumetric efficiency of an engine. What is volumetric efficiency? Volumetric efficiency is the ratio of actual volume of the air inhaled by the engine to the swept volume. What is this swept volume? When the piston comes from this TDC to BDC, a volume is swept. That volume Vs is nothing but pi by 4 d square into L. L is the stroke, when the distance covered from this TDC to BDC. D is the bore of the cylinder. Okay, so what happens, the naturally aspirated engine has this less volumetric efficiency, leading to the incomplete combustion of the air fuel mixture. So in order to get the complete and perfect combustion of the air fuel mixture, we are using turbochargers in the modern engines. This is turbo by the name because the exhaust gases which are expelled from the exhaust manifold are used to run the turbocharger. You have understood this single line diagram of this turbocharger and function of the turbocharger, how it works and how it increases the volumetric efficiency of an engine, and how it helps in the complete combustion of the fuel inside the combustion chamber. Thank you. For more technological videos, please subscribe.